Let's use Microsoft Excel to create an amortization schedule for a really simple loan. And so just to start out, I've laid out a template here, and we need some inputs that describe the loan characteristics. And so let's just grab a few numbers. Let's say the loan is a $20,000 loan to be repaid over the course of 5 years with annual payments at an interest rate of 6%. So there's our inputs. Now, you already know how to use your financial calculator to calculate the payment. You can also do that in Excel very easily with the PMT function. And so I'm going to say equals PMT, open my parentheses. Now I can go in here to my little function helper so that I can recognize what arguments go where. And so you'll see that the first argument needs an interest rate. And so that interest rate is going to be that cell there. The second argument is the number of periods. And so that cell contains the number of periods. And then the present value, or the original loan balance, goes in the third argument. Now note that both the fourth and fifth arguments are, the descriptors are not in bold type. And what that means is these are optional arguments, and they are by default set to 0 if they're omitted. And that's good, because in our loan here, those arguments should be omitted. They actually are 0. So I can click OK, and there I have my payment amount, $4747.93. Now, we have similar sign conventions in Microsoft Excel as we do in a financial calculator. We have inflows and outflows, and so the loan amount, if the loan amount is an inflow, it's a positive number, then the payments are going to be outflows because they're going in the opposite direction. To make things a little bit cleaner here, I'm going to switch the present value to a negative number, and so that's going to be this third argument. I'm just going to say negative here. And so that's going to come in negative. That makes my payment a positive number, so it's a little bit easier to work with after the fact. All right, so the payoff stream for this loan is going to have 5 payments of $4747.93 occurring at each of the next 5 years. And so what the amortization schedule does is that it lists each of these payments and describes how much principal was owed before the payment, how much interest and principal is paid as a part of the payment, and then how much principal is owed after the payment. So this is incredibly useful if you want to calculate something like a loan payoff amount. So that is, let's suppose that you make your first 2 payments of the loan, and then you want to pay it off and be completely done. You need a single number that you pay the bank to eliminate the remainder of your debt. And so that's what we're going to calculate here so far. So let's start with a little bit more preliminary information. So I'm going to link this cell here to the original balance. Okay, and so the ending principal at time 0 is going to be 20,000. And I just put that there so that I can easily link these cells back to the previous row, and we can copy down really quickly. So the beginning balance then in the first period is going to be the same thing as the ending balance in the previous period. The interest paid is simply the interest rate, so that is the cell B4, multiplied by the principal balance at the beginning of the period. So in this cell here, I'm going to say equals the interest rate times the beginning balance. And there I've got it. So the first payment is going to have an interest component of $1,200. Now, we know that all the payments are the same amount. That is this amount here. And so what that means is that everything that is not interest in this amount is going to be a reduction or an amortization of principal. And so the amortized principal is going to equal the payment amount minus the interest paid. And so these two numbers will always sum to the payment amount. And then at the end of the period, we can take the beginning principal, subtract the amortized principal, and get the ending principal balance. And so after the first payment is made, this number here, $16,452.07, is the payoff amount for the loan. All right, what I'd like to do now is just drag all of these cells down and copy them so that we can just repeat this process throughout these 5 payments. But before I do that, I need to anchor a few values so they won't copy. So the first one is in this cell. I need this to be anchored to the interest rate, so that is cell B4. So I'm going to put $signs on the B4, so that way when I copy this cell down, it will not copy this part of it down. And then second, on the amortized principal, I need to anchor that to the payment. So the payment here is in cell B6. So I'm going to put $, here, $signs around B6. So now I should be able to copy straight down. Cleaning this up just a little bit so that everything looks sort of the same. We'll put $signs and commas everywhere. And there we have it. So we have our amortization schedule. And so a few quick observations. First, look at this column. The loan goes from the full amount of $20,000 all the way down to 0. That is, the principal is fully paid off after the last payment. So that's observation number 1. Observation number 2 comes from this column. The interest component of the payment declines each period. That is because the interest is calculated based on each period's beginning principal amount. And so since the beginning principal amount declines period by period, then the interest component must decline as well. And finally, this column here, we see that the principal component of the payment increases. This is a natural consequence of the fact that the interest component decreases and the payment amount remains fixed. All right, there you have it, a simple amortization schedule.